It's hard to believe, but it's already been 3 years since NASA launched the James Webb Space Telescope, a mission that set out to uncover the universe's oldest secrets. Imagine someone saying, "Let's build a telescope that can look back in time, almost all the way to the Big Bang." Sounds crazy, right? But that's exactly what Webb is doing. Webb is helping scientists peer deep into space and deep into time to better understand how planets, stars, and galaxies come into existence, how they evolve, and what happens when they die. And along the way, it's given us some of the most breathtaking images humanity has ever seen. So, what has Webb discovered so far? Let's start with the Sombrero Galaxy. While images in visible light highlight its bright core, Webb's mid-infrared instrument reveals a much more complex structure, a smooth inner disk and clumpy details in the outer ring. Honestly, I still don't think it looks like a sombrero, but it's undeniably cool. One of Webb's most dramatic finds? A ravenous black hole at the center of a dwarf galaxy, dating back about 1.5 billion years after the Big Bang. This black hole is devouring material at over 40 times the rate we thought was even possible. It likely won't last long at this pace, but it's helping scientists understand how black holes in the early universe grew so quickly. Make sure you stick around. And if you're into deep space mysteries, consider subscribing so you don't miss what's coming. Then there's Vega, one of the brightest stars in the night sky. Thanks to both Hubble and Webb, we've got a dual perspective. Hubble shows us a smooth disk of fine dust, while Webb's infrared eyes detect a warm outer dust ring. Interestingly, Vega's disk lacks the clumps or gas you'd expect if there were big planets orbiting. So Vega might just be out there, alone, surrounded by rocks. Webb also teamed up with Hubble to create a striking composite image of two spiral galaxies mid-collision. The vivid colors highlight clouds of gas and dust, prime ingredients for star formation. It's cosmic chaos, but incredibly beautiful. And then there's Centaur 29P, a strange icy object orbiting between Jupiter and Neptune. What did Webb catch? Basically, an asteroid farting. Webb's spectrograph picked up jets of carbon dioxide and carbon monoxide blasting off its surface. Yes, even space has its weird moments. Here's another curious case. A galaxy from about 1 billion years after the Big Bang, where the gas glows brighter than the stars themselves. That's not something we typically see. Scientists think this might represent a transitional stage, linking the universe's first stars to the more mature galaxies we see later on. Next up, two galaxies crashing into each other, 465 million light-years away in the constellation Leo, one spiral and one elliptical. Webb captured how the spiral galaxy's arms are being stretched and twisted by the gravitational pull of its elliptical partner, a cosmic tug-of-war in real time. Webb has also been exploring the outer edge of our own Milky Way, an area called the extreme outer galaxy. Using its infrared instruments, it found areas where new stars are forming within two large clouds of gas and dust. These young, massive stars give us clues about how star formation works even at the farthest reaches of our galaxy. Oh, and then there's the galaxy shaped like a cosmic question mark. It's a result of gravitational lensing, where the massive gravity of a foreground galaxy bends and magnifies the light from one behind it, creating that wild shape. It's like the universe asking itself a question. Lastly, Webb has spotted some massive, ultra-bright galaxies existing just 500 to 700 million years after the Big Bang. According to everything we thought we knew, galaxies that big shouldn't even exist that early. So what's going on? New research suggests these early giants had supermassive black holes at their centers, pumping out intense radiation and possibly fast-tracking their growth. Sometimes what we see in space isn't exactly what it seems. Take some of the galaxies Webb has observed. They appear much bigger and brighter than they truly are, thanks to effects like gravitational lensing, which acts like a cosmic magnifying glass. Now let's talk about one of the coldest exoplanets ever directly observed. This gas giant, located about 12 light-years from Earth, is several times the mass of Jupiter. Its temperature, a chilly 35 degrees Fahrenheit or 2 degrees Celsius. That might not sound freezing, but in space terms, it's practically an icebox. The fact that we can now directly observe such cold planets, not just blazing hot stars, is a huge leap forward. Here's a strange one. A planet where one side is always stuck in sunrise and the other is always sunset. Using Webb's near-infrared spectrograph, astronomers discovered a temperature difference of about 300 degrees Fahrenheit between the two sides. And the hotter side? Surprisingly, it's the sunset side, not the morning one like you'd expect. To celebrate its second anniversary, James Webb delivered a spectacular infrared image of two galaxies in the constellation Hydra, around 312 million light-years away, nicknamed the Penguin and the Egg. These galaxies have been dancing and crashing into each other for up to 75 million years. One's spiral arms have been pulled and stretched into a shape that actually looks like a penguin cuddling an egg. Next up is a protostar, basically a baby star still forming. Webb captured an incredible image showing an hourglass-shaped glow created by material shooting out from the forming star. A thin, dark disk runs across the center. That's where dust and gas are feeding the young star as it grows. Webb also turned its eyes to the Serpent's Nebula and revealed something extraordinary. Several pairs of red jets blasting out from newborn stars. These jets, called bipolar jets, align beautifully with the surrounding gas filaments, supporting the idea that magnetic fields play a key role in guiding both star formation and the surrounding structure. Let's rewind time again, 6,500 light-years back, to the Crab Nebula, a remnant of a supernova in the constellation Taurus. Webb's instruments have revealed detailed filaments of gas and dust, plus pockets of new star formation in this massive cloud of cosmic debris. What about twin baby stars? Webb found a pair just 2 to 4 million years old, practically newborns in cosmic time. It even caught the jets of gas being expelled from both stars, which is part of how they shape their surroundings as they grow. Even more impressive, Webb identified 3 of the oldest galaxies ever seen, dating back just 400 to 600 million years after the Big Bang. And these galaxies are still alive, still forming stars by pulling in cold helium and hydrogen, igniting new stellar nurseries. Then there's WASP-107b, a gas giant known for its strange puffy appearance, kind of like a marshmallow. Webb discovered that its atmosphere has very little methane, suggesting the planet's interior is hotter and its core more massive than scientists thought. That explains its fluffy look. Speaking of gas giants, Webb also measured the wind speed on one about 280 light-years away. This planet is tidally locked, meaning one side always faces its star, while the other sits in darkness. That huge temperature contrast creates violent equatorial winds, blowing up to 8,000 kilometers per hour, redistributing heat around the planet like a cosmic jet stream. And now, an iconic image, the Horsehead Nebula. Webb's infrared vision gave us the sharpest view yet of this famous cloud, showing off intricate interactions between gas and dust. Still don't quite see the horse, but the science is stunning. Finally, let's talk about a starburst galaxy. Located 12 million light-years away in Ursa Major, this galaxy is in overdrive, producing new stars at 10 times the rate of our own Milky Way. And in a cold, dark molecular cloud, Webb has detected something fascinating: complex organic molecules, including alcohol. Yes, alcohol, in space. These chemicals were likely present even before stars and planets fully formed, suggesting that the building blocks of life might be more common in the universe than we ever imagined. Let's dive back into space, starting with a spectacular star-forming region in the Triangulum Galaxy, about 2.7 million light-years from Earth. This area is bursting with energy, home to over 200 young massive stars, all just beginning their cosmic journey. Now, here's one for the record books. Webb has captured one of the brightest and most distant galaxies ever discovered, shining from just 430 million years after the Big Bang. It's like looking back at the universe when it was still in diapers. One long-standing cosmic mystery may have just been solved. A supernova first observed back in 1987 has kept astronomers guessing for decades. What's hiding at its core? Thanks to Webb, we now have strong evidence that it's a neutron star, an incredibly dense object formed in the explosion's aftermath. Interestingly, some early galaxies look nothing like the spirals or ellipticals we're used to. Instead, they resemble pool noodles or surfboards, long, narrow shapes that challenge our understanding of galaxy formation. Then there's this strange dust cloud that kinda looks like a cat's tail. Not exactly scientific, but definitely memorable. In another stunning find, Webb detected auroras on a brown dwarf, a kind of failed star, just 65 light-years away. These auroras, similar to Earth's northern lights, are likely caused not by a host star, but by the brown dwarf's own magnetic field interacting with nearby ionized gas. That's like a planet throwing its own rave. No sun needed. Webb also turned its gaze toward Uranus, and wow, did it deliver! Using its near-infrared camera, it revealed 11 of the planet's 13 known rings, including the faint and rarely seen Zeta ring. It's a delicate structure that we're only now seeing clearly, thanks to Webb's incredible sensitivity. Here's a look at what's left after a supernova. A high-resolution view of the exploding star's shell, now expanding through space. Bright orange and pink clumps made of sulfur, oxygen, argon, and neon paint a hauntingly beautiful picture of cosmic destruction and creation. Another highlight, a Herbig Haro object, a glowing region surrounding a young protostar. These form when jets of gas from the baby star slam into nearby dust and gas, creating shockwaves that light up space like a fireworks show. Webb has even zoomed in on the core of our own Milky Way, revealing nearly 500,000 stars packed into an incredibly dense region. And for the first time, we're seeing bizarre, bright blue needle-like structures, features we've never seen before. In a powerful collaboration between Webb and Hubble, we also got a vivid wide-spectrum image of a galaxy cluster. Webb's infrared vision, combined with Hubble's visible light, reveals a kaleidoscope of galaxies spread across time and space. Some of these galaxies are so faint and far that we'd never see them without this blend of light. Webb also made headlines by spotting a fast-moving jet stream on Jupiter. This newly discovered current stretches over 4,800 kilometers wide and blows at over 500 kilometers per hour, sitting about 40 kilometers above Jupiter's main cloud layer. It's another puzzle piece in understanding the gas giant's chaotic atmosphere. And then there's Europa, Jupiter's icy moon. Webb detected carbon dioxide on its surface, specifically in a region called Tauro Regio. The source? Most likely Europa's subsurface ocean, not space debris or meteorites. That's huge, because carbon is a building block for life. Here's a truly mind-blowing discovery. Earendel, the most distant star ever detected, located a whopping 28 billion light-years away. It lives in the Sunrise Arc galaxy. This massive B-type star is more than twice as hot as our Sun, and around 1,000,000 times brighter. The only way we can see it is because its light was magnified by gravitational lensing, an extraordinary cosmic coincidence. Next, we have a galaxy cluster with a nickname that fits, El Gordo, or the Fat One. Its immense gravity warps the light from galaxies behind it, producing incredible gravitational arcs, beautiful distortions caused by its sheer mass. And finally, another Herbig Haro object, this time created by a pair of actively forming stars about 1,470 light-years away, in the constellation Vela. Their bipolar jets, streams of material ejected in opposite directions, have been blasting through space for thousands of years, sculpting the environment around them. Let's start with something explosive. Literally, when young stars shoot out jets of gas at high speeds, those jets slam into surrounding dust and gas, creating shockwaves that light up space in dazzling colors. Thanks to Webb, we're now seeing these interactions with unmatched detail. Next, a huge leap in the search for life. James Webb has detected water vapor in a distant solar system, right in the Goldilocks zone, the region where temperatures are just right for rocky, Earth-like planets to form. This is the first time water's ever been observed in this sweet spot of a system known to host protoplanets. That's big. To mark its first birthday, Webb gave us a gift, a stunning image of a nearby cloud complex, the closest star-forming region to Earth. This high-res snapshot shows dozens of young protostars and their energetic jets lighting up red molecular hydrogen as they crash through interstellar gas. Now let's talk dust. Webb captured 2 incredibly dusty supernovas, and that's not just a poetic detail, it's scientifically important. These observations confirm that exploding stars are major contributors to cosmic dust, helping explain why early galaxies were so dusty and how that dust spread across the universe. Here's something wild. Webb discovered a cosmic web made up of 10 galaxies, all dating back to just 830 million years after the Big Bang. This is one of the earliest examples of large-scale structure formation in the universe, offering fresh clues about how gravity shaped the cosmos. Take a look at this gorgeous barred spiral galaxy, about 20 million light-years away in Virgo. That bar? It's not just a pretty feature, it helps funnel gas into the galaxy's core, fueling intense star formation right at the center. Now we turn to Saturn's moon Enceladus, where Webb spotted a massive water vapor plume erupting from the South Pole. It stretches over 9,600 kilometers. That's 20 times the moon's diameter. This is direct evidence that Enceladus's underground ocean is spewing material into space, even feeding Saturn's rings. And yes, where there's water, there could be life. Then there's this mini Neptune, orbiting a star about 40 light-years away. Webb found its thick, hazy atmosphere highly reflective and loaded with water vapor, suggesting a hot, steamy environment. It's not exactly vacation-worthy, but it's a fascinating step in understanding exoplanet climates. Here's another gem. A blazing infrared galaxy formed by the collision of two spirals in the constellation Serpens. This ultraluminous infrared galaxy, the closest one of its kind to Earth, is churning out stars like crazy. Webb spotted 200 massive star clusters packed into a region just 5,000 light-years wide. A cosmic fireworks show born from galactic chaos. Now for something closer to home. Cassiopeia A, the youngest known supernova in our galaxy, about 11,000 light-years away. Webb's detailed infrared images show intricate clumps of material and diffuse emissions in the expanding debris field, shedding light on how elements are scattered across the universe after a star explodes. One of the hottest finds? TRAPPIST-1b, a rocky planet just 40 light-years away. Webb measured its dayside temperature at a scorching 232 degrees Celsius, which strongly suggests it lacks an atmosphere. Without an atmosphere to move heat around, one side cooks while the other freezes. A barren, lifeless rock. Next, meet a star on the brink of destruction. A Wolf-Rayet star, massive and bright but doomed to die in a spectacular supernova. These stars live fast and die young. Perfect candidates for Webb to observe the moments before stellar death. And speaking of drama, take a look at Pandora's cluster, a cosmic mega-merger of three galaxy clusters, forming a gravitational lens that magnifies galaxies far behind it. This deep field image gives us one of the clearest looks yet into the early universe and the massive forces shaping it. Finally, something small but no less impressive. Webb detected an asteroid between 100 and 200 meters wide in the asteroid belt between Mars and Jupiter. On its own, it's not remarkable, but it shows that Webb's precision isn't just for distant galaxies. It can also track objects in our own solar system. And who knows, one of these small rocks might matter a lot, especially if it heads our way. And here's something wild. Imagine two planets colliding so violently that they leave behind a dusty disk. Yep, that's exactly what you're looking at here. Thanks to the James Webb Space Telescope's near-infrared camera, NIRCam, we've got the clearest view yet of this leftover chaos. For the first time, scientists have imaged it in this specific infrared light, revealing the inner regions in stunning detail. Next up, we travel 200,000 light-years away to the small Magellanic Cloud, home to a bustling, dynamic star-forming region. Webb's infrared camera revealed dense clouds of dust and hydrogen, the raw ingredients needed to form stars and planets. It's like peeking into a cosmic nursery. In the Carina Nebula's famous cosmic cliffs, Webb uncovered jets and outflows from baby stars. Using the infrared camera, it detected molecular hydrogen, a key player in star formation, helping us understand how stars are born, right from their earliest moments. Here's something a bit more intricate. The Southern Ring Nebula. Its beautiful curvy shapes come from complex interactions between at least two, possibly even three, hidden companion stars. By combining Webb's images with data from ESA's Gaia mission, scientists even figured out the mass of the star that shed its outer layers to create this nebula. It's a cosmic dance that shaped its signature look. And now, an eerie masterpiece, a mid-infrared image of the pillars of creation inside the Eagle Nebula. Unlike earlier images, this version cuts through the starlight and highlights just the gas and dust. It's haunting, detailed, and purely focused on the building blocks of new stars. From there, let's go back 11.5 billion years. Webb spotted a massive cluster of galaxies forming around a glowing red quasar, a young superactive galaxy cloaked in thick cosmic dust. The red color comes from that dust, and the whole scene gives us a rare glimpse into how galaxies and the larger cosmic web came together in the early universe. Now this next one looks familiar for a reason. Webb captured at least 17 concentric dust rings around a binary star system. These rings form every 8 years as the two stars orbit closer to each other, their stellar winds smashing together and creating expanding shells of dust, kind of like tree rings in space, each one marking a chapter in their orbit. Here's something historic. For the first time, both James Webb and Hubble observed the same cosmic event together. It was NASA's DART mission, where a spacecraft deliberately crashed into a small asteroid to test planetary defense strategies. This coordinated observation gave us a clearer picture of the impact than ever before.